Okay, number one, step one. You guys remember when you had to find the least common multiples of the x's and y's? Well, now you have to find the least common multiple of the x's, the y's, and the z's. Okay? So it's the same thing, you just got to have an extra one. Okay, so let's go ahead and do the x's. 2, because I have 1, 2, and negative 1. Okay, all three of those go into 2. What about the y's? 1, negative 1, and 2. So that one's 2 as well. What about the z's? Yeah, 2 as well. So they're all 2. So is there any that's a lot easier than the other one?
No.
The x's? You want to choose the x's? I would say x's, y's, or z's. It doesn't, honestly, it doesn't really matter in this case.
Wouldn't the z's be easier? Because you just have to add the two together. The first.
Yeah, you could. Yeah, you could do the z's. You could do that for the x's, first and third too.
Oh, yeah.
So yeah, basically here's the deal. Okay, the first thing you're going to do is choose 2 equations. Okay, choose 2 of the equations and eliminate one of the 3 variables. I'm going to say that again. Choose 2 of the 3 equations. Here's equation number 1. Here's equation number 2. Here's equation number 3. Okay, this is problem number 1. Choose 2 of the 3 equations and eliminate one of the variables. So if I were you, or if I were me, I would eliminate this x and this x because we don't have to do anything to the equations, right? Or this z and this z. Or this y and this y. It doesn't matter. Pick one. Okay, so I'm going to do the x's. And I'm going to pick equation 1 and 3. And I'm going to eliminate the x's. This is how I start. Always write that down. Question. Okay, the x's have the coefficient of 1, 2, and negative 1. What do all 3 of those numbers go into? Yeah. Okay. All right. Now, write down equation 1 and 3, because that's what we chose, so we can get rid of the x's. I have x plus y plus z equals negative 1. Then I have negative x plus 2y minus z equals 4. And add them together. What?
Oh, no, I thought you wanted the answer.
No. Okay, add them together. X minus x, or x plus negative x, cancels out. Y plus 2y is 3y. Z minus z, those cancel out too. That's very convenient. You'll see why here in a second. So I have 3y equals negative 1 plus 4 is positive 3. So right away, we got rid of 2 variables and we weren't even trying. Okay? We weren't even trying. But we're going to come back to that. Just leave it there. Okay? And here's how I do it. When I sometimes use colored pencils, or I put this in two separate boxes so I can keep my stuff organized. I'm going to use 2 separate colors. I use blue for the equations 1 and 3. I'm going to use black for equations that are left over. Now, when you do the second set of equations, you must choose the one that you have not used the first time you did it. So which one didn't I use yet? I didn't use number 2, right? Because I used 1 and 3 in the beginning. So when you start your second round of equations, you have to use the one you didn't use. In this case would be number 2. Set equation number 2. Okay, equation 2, and then you can pick either 1 or 3. It doesn't matter. Whichever one is easier to make it eliminate. Okay, so I'm still eliminating the x's. Still eliminating x's. Because that's why I wrote x's here. When you do the next 2 equations, no matter what you choose, you still have to eliminate x's. You can't switch what you eliminate. That is the number 1 mistake students make. When you choose the second set of equations, what they'll do is they'll eliminate y's, and they're like, wait a minute, this doesn't work. You must eliminate the exact same thing the first 2 times you eliminate. I promise somebody's going to do that. Okay, don't do that. So I have equation 2. Well, I'm still eliminating x's. I would choose equation 3 since it's already negative. I want a positive negative 2. So I'm going to choose equation 2 and 3. You can choose 1, it's fine, but I would choose 3. Equation 2 is 2x minus y plus 2z equals negative 5. Equation 3 is negative x plus 2y minus z equals 4. Now, if I add these, does that eliminate the x's? No. What do I have to do to the second or the bottom equation in order to be able to eliminate them? Multiply the entire equation by 2. Multiply the entire equation by 2.
Even the 4?
Everything. The entire equation by 2. Now when I find the new equation so that I can eliminate, okay, I'm going to go ahead and distribute this. I get negative 2x plus 4y minus 2z. Make sure you distinguish between your 2's and your z's. It gets confusing if you don't. That's why I always put a line through my z's, so you don't think it's a 2, especially if you make your 2's like that. Okay, so put a line through your z's. Equals 2 times 4 is 8.
So where'd you get that 2 to distribute at?
I made it up so that when I add the x's together, they cancel out. You get to choose what number you'd multiply it by. And I chose 2 so that my x's would eliminate when I add them.
Okay.
I want one to be positive 2 and one to be negative 2. If this would be 4x, I would choose 4. Does that make sense?
Mm-hmm.
Okay. So now I'm going to rewrite this equation since I have lines all over it, so that when I add it, I don't make a mistake. So I have 2x minus y plus 2z equals negative 5. So I rewrote that so that when I add them, I can eliminate my x's without messing up. You can't skip steps when you do these, because if you make one tiny error, it's going to mess up the entire thing. Okay? You have to be very careful. One addition, subtraction, or multiplication error is going to mess up everything. You're going to get crazy answers. Okay? Decimals and funky fractions. Every once in a while, I'll give you a fraction one. Most of the time, I'm going to give you a whole number ones. Okay? So now when I add these, I have negative 2x plus 2x cancels. 4y plus negative y is 3y. Negative 2z plus 2z, those cancel as well, equals
3.
3.
It's the same.
What's that?
I said it's the same.
What's that? Yeah, this one is a lot easier than most of them, and I'll show you why here in a minute. Yeah, we're going to do another one. Okay, now we're going to find out. Can you find what y is using these two? Yeah, you can find out what it is. So what I'm going to do is divide both sides by 3. You can do it to either one and have y equals 1. Okay, so now I have y. I know what y is. How can I find x and z? Do the exact same thing. Plug in your y value for all of your equations. Choose 2 of them and solve for x and z. You understand? And I'll show you. I'm going to do it. Okay, I'm going to do it on another piece of paper beside this one so you can see. Okay, so here I am. I'm going to take equations 1 and 2 and plug in 1 for y. Okay, I'm going to take equations 1 and 2 and plug in 1 for y. So I have x plus 1 plus z equals negative 1. I have 2x minus 1 plus 2z equals negative 5.
That's just
Do we put y's?
answer.
Yes.
Yeah.
Oh, I'm not going to add them yet. I lied. Hold on.
Do we put y's?
Yeah, plug in your y's. You're plugging in the y's. Now, take your y value over to the other side. So you just have x's and z's. Okay, so in this case, I'm going to subtract 1, and I'm left with x plus z equals 0. Or, I'm sorry, negative 2. The negative 1 minus 1. And then I'm going to move this one to the other side. I'm going to add 1. That cancels this out. So I have 2x plus 2z equals negative 4. Now, you have 2 equations with 2 variables. You've done these already. You should be fine. We're going to review in case you forget. But the first thing I want to do is look at my x's and z's and figure out which one I want to eliminate. Well, they're both exactly the same, 1 and 2, 1 and 2. So both of them are 2. Oops, that's a z. So what do I need to multiply the top one by?
2.
Negative 2. Okay, multiply it by negative 2. Why negative 2, Madison?
So that and the x's cancel out.
Yeah, so when I add in the x's cancel out. Okay, we're still eliminating x. So I have, to distribute that, I'm going to get negative 2x minus 2z equals 4. Okay. What's going to happen?
We're all going to cancel out.
So what's going on? Everything's going to cancel out.
You can't have 0 equals 4.
Cancels.
Oh.
Why is there no solution?
Cancels out.
No. Remember, when we had 2 by 2s and there was no solution, what kind of lines did we have?
We had
Parallel.
weren't they straight?
What?
Parallel.
Parallel. Remember, parallel lines don't have a solution, right? Well, guess what? Is it possible to have 2 lines in outer space or in 3-dimensional space that never intersect?
Yeah. You're talking about space, they float across.
Right?
Is that key line? Now you gotta
So
find
what's
out.
going on? Either I have the same line, or I have lines that don't intersect. Which do I have?
Same line.
Look at the 3 equations. Which 2 are the same? Or is one the equivalent of the other?
1, 3, and 2. Loki. 1 and 3 and 2. 2 and 3.
They're not the same.
2 and 3. Right?
None of them were supposed to be.
Yeah. This is just a special situation. Okay, and I did this one on purpose. Okay, that these lines don't intersect, so there's no intersection point. So it means it's no solution.
Tom's done?
You know what? I went to the whole. Can I have another homework? What did the y equal the same thing?
Because equate those ones. Okay. Question.
I have another homework.
So once you have one no solution, like the whole problem is no solution.
Yeah. Pretty much.